Welcome to solverfy.
In this problem, we have a radio broadcast that's being sent out with a power of no more than 25 kilowatts, and in order to be received and understood, the electric field strength at a given distance has to be at least 0.02 volts per meter. And what we want to know is what is the maximum distance that the signal can be received at. And something that's important to consider is that the intensity, the average intensity of this broadcast at a certain distance can be defined as the average power divided by the area across which the signal is distributed. So initially, when the broadcast is first sent out, all of its power is concentrated at a single point. But as the waves start to emanate outwards, the signal is distributed across a sphere of a certain area, which is determined by the radius r of that sphere. And we know that the equation for the surface area of a sphere is 4 pi radius squared. And we also know that intensity can be written this way as 1/2 times vacuum permittivity of free space, epsilon naught, times the speed of light, times maximum electric field strength squared. So we're given this average power. 4 pi is, of course, a constant. Epsilon naught is a constant. Speed of light is a constant. And we're given our electric field strength. So now we should be able to isolate for radius and just plug in our values and solve. So if we rearrange this a little bit, we can find that radius equals square root of average power divided by 2 pi epsilon naught speed of light electric field strength squared. And now we can just plug in our values for each of these objects. So we know that our average power is 25,000 watts. I'm gonna leave myself some more room here. We have 2 pi in the denominator, and this vacuum permittivity, this epsilon naught term, is a physical constant, which is known to be 8.85 times 10 to the negative 12 joules per volt squared times meters. And speed of light is, of course, 3 times 10 to the 8th meters per second. And our electric field strength is 0.02 volts per meter, and that is squared. So if we plug all of this into a calculator and round to 2 sig figs, we find that this comes out to be 61,000 meters. We'll say about equals 61,000 meters, which is equal to 61 kilometers. And that is your answer.